Hi friends, myself R.D. Mahajan presenting my one more video on solution of partial differential equation by method of separation of variable. In this video, we try to find the solution of dou to u by dou x dou t is equals to e raised to minus t into cos of x, and the conditions are u of x 0 is equals to 0, means when t is 0 the value of u is 0, and the second condition dou u by dou t is equals to 0 when x is equals to 0. Therefore, using this condition we try to find out the values of arbitrary constant. Here the given differential equation is dou to u by dou x dou t is equals to e raised to minus t into cos of x. We call this as equation 1, where u is a dependent variable and x and t are two independent variable. Therefore, let solution be u is equals to a product of capital X into capital T, where that capital X is a function of small x and capital T is a function of small t, and we call this as equation 2. And then differentiating it with respect to x, differentiating to first with respect to x, keeping t constant, we get dou u by dou x is equals to x dash into t constant outside, and derivative of x is x dash. Then whatever this result, we differentiate with respect to t, keeping x constant. Therefore, we get dou to u by dou t into dou x is equals to x dash constant outside, and derivative of t is t dash. And whatever this value, we substitute in equation 1. Equation 1 becomes, put it in 1, we get x dash t dash is equals to e raised to minus t into cos of x. And then separating the variables, collecting the terms of x dash and function of x on one side and e raised to minus t and t dash on the other side. For that, I will transfer this term to left. We get x dash divided by cos x, and that is equals to e raised to minus t divided by t dash, equal to arbitrary constant kc. Then equating first with last, we get x dash divided by cos of x is equal to k, and e raised to minus t upon t dash is equals to k. Then it gives you x dash is equals to k into cos of x, and here t dash is equals to 1 by k into e raised to minus t. And then after getting the values of x dash and t dash, we try to integrate it with respect to that variable. Integrating this, we get x dash and its integration with respect to x, k constant outside, integration of cos of x with respect to x, integration of x dash with respect to x is x capital is equal to k, integration of cos is sine plus constant of integration c1. We get the value of capital X as k multiplied by sine x plus arbitrary constant c1, or constant of integration as c1. Then integrating this second term with respect to t, we get integration of t dash with respect to t, 1 by k constant outside, integration of e raised to minus t with respect to t, integration of t dash is t capital, 1 by k integration of e raised to minus t is e raised to minus t upon minus 1 plus constant of integration c2. Then substituting these two values in that required solution, therefore u is equals to, we have x into capital T. Substituting the values, we get value of x as k sin x plus c1 multiplied by 1 by k with minus sign e raised to minus t plus c2, and we call this as equation 2, equation 3. Solution in terms of x and t, small t, where k and c1 and c2 are constant terms. Then using first condition, u of x0 is equals to 0 in 3, means substitute t is equals to 0. At that time the value of u is 0 in equation 3. Left hand side is 0, right hand side is k sin x plus c1 multiplied by, when t is 0, e raised to 0 is 1, therefore we get minus 1 by k plus c2. Here the product of two terms is equals to 0, out of which when t is 0, x is not equals to 0. It implies if this term is not equals to 0, it implies second term must be 0, and that therefore we get minus 1 by k plus c2 is equals to 0. It gives you the value of c2 as 1 by k. Once again I will explain this concept. Whenever we have a product of two terms at 0, out of which one term is not equals to 0, it implies second term must be 0. Using that concept we get second term 1 minus 1 by k plus c2 as 0. From this we get a value of c2 as 1 by k. Using this in 3, we get u is equals to k sin x plus c1, k sin x plus c1 multiplied by c2 is equals to 1 by k, therefore it is 1 by k and minus 1 by k into e raised to minus t. If we multiply by 1 by k inside this, we get that k get cancelled, we have only sin x plus c. Differentiating that equation 4 with respect to t, differentiating 4 with respect to t, keeping x constant, and therefore derivative of that u with respect to t is dou u by dou t. With respect to t, this term is a constant term, therefore sin x plus c1 by k we take outside, and differentiation of e raised to minus t is e raised to minus t into minus 1, that minus and this minus it become plus, therefore it is e raised to minus t. We call that equation 5th. Using condition dou u by dou t is equals to 0 when x is equals to 0, in 5th we get left hand side is 0, right hand side is, that term becomes sin 0 is 0, plus c1 by k into e raised to minus t. Once again, it is c1 by k into e raised to minus t. A product of two term is equal to 0. When x is 0, t should not be 0, as t is not equals to 0. What it implies? Second term must be 0, and here the second term is c1 by k is equals to 0. Substitute that in fifth. Substitute in fourth. Put it in equation 4. We get u, which is a function of x and t, is equals to c1 by k is equals to 0, means we have only sin x, multiplied by 1 minus e raised to minus t as the required solution or the required answer. Therefore, solving this partial differential equation by method of separation of variable, we get the solution as u is equals to sin x multiplied by 1 minus e raised to minus t. If you like my video, please share it, as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you for watching.